Sound. You're hearing it right now. Sound is made by waves that arise from a vibrating source. These waves make disturbances through the air until they can be picked up and perceived by an observer. Before we talk more about sound though, let's first discuss waves. When the word wave is said, an image of the beach may come to mind. But that is just one kind of wave. There are radio waves, electromagnetic waves, seismic waves, X-rays, ultraviolet light, and sound waves, just to name a few. But the waves like you see in this image can be portrayed in a different way. It shows what a standard wave looks like. The amplitude, represented by a capital A, is the value of the maximum displacement from the equilibrium value, represented by the black line. The amplitude's unit of measure is a meter. The wavelength is the measure of distance from two successive points in a wave, such as the two crests in the graph. It is represented by the Greek letter lambda. Its unit of measure is also a meter, and it can be quite big or very small depending on the wave. The period, represented by the capital T, is the measure of time in seconds it takes for a wave to complete a movement to the next successive point, such as the crest of the wave. Frequency is the reciprocal of the period and is equal to 1 divided by the value of the period. Frequency is measured in hertz. The wave speed, represented by v, is the velocity of the wave in meters per second. It can be found using the formula wave speed is equal to frequency times wavelength. Now that we have discussed the basics of waves, let's talk about sound. If you've ever been to a military air show, you know that there are many loud jet engines running throughout the event. If you didn't buy any souvenirs and were like me who forgot to wear ear protection, you would bring home some ear pain. This pain is because the sound of an air show easily exceeds the threshold of pain. Sounds of an intensity of 1 watt per meter squared, or 120 decibels, are at the limit the human ear can tolerate. A jet engine in close proximity to an unprotected human ear can reach 140 decibels, about 100 times over the human pain threshold. Now let's talk about the equations. The equation, decibel is equal to 10 times log of the intensity of the given sound over the intensity of the threshold of hearing, is used to find the decibel level when intensity is provided. Rearranging the equation to 10 to the power of decibels divided by 10 times the intensity value of the threshold of hearing, which is 1 times 10 to the power of negative 12 watts per meter squared, will provide intensity of the sound. The Thunderbirds always use 6 General Dynamics F-16 Fighting Falcon fighter aircraft during their demonstrations. These single-jet engine aircrafts each produce 140 decibels at a close but not immediately near distance. Today we will try to find the decibel value of the whole United States Air Force Thunderbirds Air Demonstration Squadron prior to takeoff. If we simply multiply the 140 decibel value by 6, we would get 840 decibels. That value is greater than the explosions of Tsar Bomba, the Krakatoa eruption, and the bombings of Hiroshima and Nagasaki combined. Because the United States Air Force doesn't reduce the Las Vegas Valley to ash every other Veterans Day, this answer can't be correct. Remember that the decibel value is logarithmic, meaning something 10 decibels higher is 10 times louder to our ears. If you want to find the correct answer, let's first find the intensity of a single F-16 engine. Use the intensity variation of the decibel formula. I is equal to given decibels divided by 10 times the intensity of the threshold of hearing to find the intensity of a single F-16 jet engine. Remember that decibels is equal to 140. Intensity is equal to 10 to the power of 140 divided by 10 times 1 times 10 to the power of negative 12, which is equal to 100 watts per meter squared. Now multiply that value by 6 to find the intensity of the full Thunderbird squadron. This will give you an intensity of 600 watts per meter squared. Now let's work to find the decibel value of the demonstration squadron. Use the equation decibel is equal to 10 log intensity of sound over intensity of the threshold of hearing. Plug in values so that decibels is equal to 10 log 600 over 1 times 10 to the negative 12. You will get the result of decibels equal to 147.8. Maybe the squadron wasn't as loud as you were hoping, but anyone sitting around these jets daily would quickly lose their hearing. No wonder they wear ear protection. This was a demonstration of using sound waves to determine the decibel volume and intensity of a squadron of F-16 fighter jets. Thank you for watching and have a good day.